This here is a graph of 10,000 links. It's so big that I actually need to zoom in. This is the result of my webbot crawling through websites, gathering links, and creating this visual representation of those websites, where they go, and so on. Here, for example, we have an Adobe link, and we can see all of the different links that it goes to from this website. So it's actually a pretty neat project. If you want to find out where's the website generating its traffic, or where is it linking to, for research purposes or for personal. So that's what we are going to be doing today, and stay tuned and enjoy. What's up, ladies and gentlemen, business engineer here, back with another awesome project. So you've seen in the intro what we will be doing, so I'm just gonna go jump into the code and start up. So the requirements, all what I did, basically I installed Scrapy and Scrapy fake user agent and Scrapy proxies. As well as let me find it. I installed Graphiz. We will basically be using Graphiz to make our graphs. Python has a wrapper around Graphiz's source code, which is written in Dot, which is actually a nice extension for us, so we could use it. So jump into the settings. So here's nothing unusual, except we make this to false. So if some data is lost, we try to reconnect to the request. These are basic settings for the user agent and the proxy, same as this as well. And here are some custom HTTP headers that I defined. Uncommented this pipeline, and I enabled HTTP cache. If you are doing some testing, just in case, enable it. Your requests will be much faster and you'll save plenty of time. So our imports, we have a link extractor, crawl spider rules, another link extractor, then we have a close spider exception, and unquote from URL libs. We leave the start URLs empty, and we define a rule with a link extractor in it. We're basically allowing everything inside of the link extractor. And for the rule, we make follow through, since we want to follow up our links, and we give it a callback. So in the initialization, we give it a non-URL, since, well, we want our user to define the URL, and we set the link's default value to 100. And as well, we make a counter and we make a list for our links. Next, we check if the URL is none. If it's none, we raise a type error asking the user to input some URL by giving it an example and calling the super constructor argument. So here in the callback, we are checking if the counter is higher or equal to the number of links provided. We raise a close spider exception, calling done. Next, we are parsing the link from the response. Basically it goes to this function, it unquotes the provided link, and it splits the link up starting from here so that we won't get the HTTPS or HTTP prefix. Then we check if the link is too long, we're splitting it up. So basically this splits up any subdomains or subdomain URLs that the link has. So for the denied URL, basically we are doing the same as this here, and we are providing it in the link extractor loop. The same here, we're allowing everything and we're denying the URL that is currently being scraped. That way we say that we want only the external links and we don't care about the internal ones, and we extract links based on this response. So inside of the loop we parse the link same way. We set the item to the link that we're scraping through and the link that's being found on this URL. After that we append this dictionary to our list, we yield it, we increment the counter. And the same principle as at the beginning of the function. We're double checking it just in case, since this is actually a bit buggy. I've tested it out, and when I've hit like 100 links, it's still scraped up to 120. So double checking just in case. And after that's done, we are actually moving to the pipelines. So we are using Graphiz and JSON here. In the constructor, we are initializing the Graphiz's diagram, assigning it an engine. Basically it has Nito and the dot engine, if I'm not mistaken, the file name and the format we want. The other one is PDF, but the PNG works way better. It also accepts some node attributes. Basically you can style our nodes. The Graphiz's documentation has all the available functions that we can use. And for the edge attribute we give it a weight of 10. Next, we give it attributes for the graph itself. The size is 100. We set the overlap to false and the font size to 150. Since the image will be quite big and we will be needed to zoom in quite a bit. This is left empty, and when the spider is closed, basically what we're doing here, we're creating a new dictionary with a key of data. This key is a list. And next, we are looping through every element inside of the link set that was inside of our spider, which is basically this. And we're adding every element to this new dictionary. We are doing this just to filter out the duplicate values. We don't want any duplicates. And so yeah. Next we create a new file and we dump this dictionary inside of this file. I'm using a list, since without it I got some weird type errors that I couldn't get around, and the workaround to it was like passing it as a list. This was the original way that I tried to dump it, or even without the data, it didn't work. So we write the file to JSON, we close it. This is simply a backup, since some of the links are too long, they pass through, and if the link is too long, then the diagraph gives us an error or doesn't even show us the graph itself. So next we simply iterate through the list. We assign the head as an original and the tail as found, and we create the edge like this and show ourselves the graph. So a small example, let me actually open this up, and we need a random website. Let's Google for buy iPhone. And let's take, we need some e-com website. Let's actually go to Amazon. Nah, this is too big. Let's try this one maybe. Yeah, perfect. So I'm gonna copy the link. I'm gonna go to here, scrapey crawl. I'm not providing any links since the default one is set to 100, and I'm gonna change this to 4 just in case we won't override it. So as you see, we're looking for some external links. Here we are at a different link. As you see, here are duplicates, which is why we needed to filter out them actually. And here you see actually the count of links that you get. Oh, it's done. Corporate, weekly target, target. If we take a look at the debug, basically here you can see it's actually targeting every one of these. The same here. This is the same, and every other one is the same. Let's actually try to increment the links to 1000. I'm gonna come back when it's done. So this is the result. We need to zoom in. Oh, and we actually got way more than the first time. Let's actually find the website that we were scraping for. Nope, not here. Where is it? Oh, here it is. So, this was the base website that we were scraping for, and it went to here, 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 here to help the target, and so on. It's a pretty decent project. I enjoyed making it, and even more I enjoy seeing the results. So I hope you enjoyed. Hit like, subscribe, and definitely hit subscribe to see some more awesome projects like this. And see you till next time.